Hi, this is Leah Applegarth. We're going to go over Chapter 5, Section 3 in Advanced Algebra 2. The topic is solving polynomial equations. Our learning objective is to solve polynomial equations by factoring and to solve polynomial equations by graphing. So we are going to factor our polynomials ax squared plus bx plus c so that we can solve equations for when that polynomial is equal to 0. From the last section, we know that if x minus a is a factor of a polynomial, then the polynomial has a value 0 when x equals a. If a is a real number, then the graph of the polynomial a comma 0 has an x-intercept. To solve the polynomial equation by factoring, we write the equation in the form p of x equals 0, and then we factor p of x and use a zero product property to find the roots. So let's see what that looks like. We're going to answer the question, what are the real or imaginary solutions of each equation? So what we're going to do is take each piece and we're going to say x squared minus 1 equals 0. And x squared plus 4 equals 0. And then we're going to add 1 to both sides here. And we get x squared equals 1. I'm going to take the square root of both sides. And I get x equals plus or minus square root of 1. Where x is equal to plus or minus 1. So the zeros, 2 of the zeros to a are 1 and negative 1. I'm going to continue to solve this and get x squared equals negative 4. Take the square root of both sides. And I get x is equal to plus or minus the square root of negative 4. Well, we're going to divvy that out. We're going to say x is equal to plus or minus the square root of negative 1 and 4. So let's simplify that further and say that x is equal to plus or minus square root of negative 1 is I, and the square root of 4 is 2. So the real or imaginary solutions are 1, negative 1, 2i, and negative 2i. All right, so we're going to do the same thing over here. We're going to use this property that we want to write our equation in the form of p of x equals 0. So we're going to move everything over, and I'm going to do that by subtracting 5x to the 4th. And adding 2x to the 3rd. When that happens, I get x to the 5th minus 5x to the 4th plus 6x cubed equals 0. Then I'm going to go ahead and I'm going to factor out 3 x's. So I'm going to go x to the 3rd. When I do that, I'm left with x squared minus 5x plus 6. And then I need to find two numbers that multiply to give me positive 6 and add to give me negative 5. So that's negative 2 and negative 3. Then I'm going to have the zeros. We got x cubed equals 0. We have x minus 2 equals 0, using that zero product property. And x minus 3 equals 0. This gives us, if I take the cubed root of both sides, the cubed root of 0 is 0. If I add 2 to both sides, I get x equals 2. If I add 3 to both sides, I get x equals 3. So in this case, my zeros are 0, 2, and 3. Okay, polynomial factoring techniques. So there are several different techniques we can use. We can factor out the greatest common factor. So like we did in this problem up here, we can find a common factor. In this case, it's 5x squared. And we can factor down as far as we possibly can. We can use quadratic trinomials. So in the case of like 6x squared plus 11x minus 10, we can factor it into its two binomials. Please make sure you write these equations down. Perfect square trinomials. When we have a perfect square trinomial with addition in the middle, we write that as the first term squared, the double the first and the second term multiplied together, and then that last term squared. If I have, instead of a plus b, if I have a minus b, I do the same operation except I have a minus in front of my 2 times the terms multiplied. Difference of squares, if I have a squared minus b squared, that is the same as a plus b times a minus b. We can factor by grouping. This is something that we haven't really done since Algebra 1, so please make sure that this makes sense to you. If it doesn't, I can help you get some more practice. So what we do is we group these guys together, and then we factor out twice what they have in common. So I'm going to, from this grouping, I'm going to factor out the a, and from this grouping, I'm going to factor out the b, and then as you can see, they both have an x plus y in common. So I'm going to factor that out, and when I do, I'm left with a plus b. So by grouping, you can also factor some pretty tricky polynomials. Sum or difference of cubes. So if I have a perfect cube plus a perfect cube, I can rewrite that either as a plus b times a squared minus ab plus b squared. And if I have the difference of cubes, I can write that as a minus b times a squared plus ab plus b squared. Okay, let's go set about to factoring. So let's apply that. What are the real or imaginary solutions of each polynomial equation? So I am going to move the 16 over. So I have x to the 4th minus 16 equals 0. And then I know that x to the 4th is a perfect square. He is x squared squared. And then 16 is a perfect square. He is 4 squared. So my a is x squared, and my b is 4. A is x squared, b is 4. So I'm going to use the difference of squares. So I can write that as a plus b times a minus b. So I'm going to write it as a plus b times ba minus b equals 0. And then I am going to, oh, that was abrupt. I'm going to go ahead and I can factor this one a little bit more. Not this one, he's kind of stuck where he is. This is the difference of squares. So I can write him as x minus 2 times x plus 2 equals 0. And then now I use the 0 products property. X squared plus 4 equals 0. X squared equals negative 4. X is equal to plus or minus the square root of negative 4. And so x is equal to plus or minus 2i. Because a negative 1 gets to be the I, and the square root of 4 is 2. then I have x minus 2 equals 0 and x plus 2 equals 0, leaving us with x equals 2 and x equals negative 2. So all of our zeros here are x equals plus and minus 2i and plus and minus 2. Okay, so once again, for B, we are going to move all this over. So I'm going to subtract 8x and add 2x squared. I get x cubed minus 8x. Actually, I'm going to put the 2x squared first. Minus 8x equals 0. I'm going to go ahead and factor out an x, since they all have that in common as a factor. And I want two numbers that multiply to give me negative 8 and add to give me positive 2. So let's see, that's 4. If I go plus 4 minus 2. That'll give me positive 2. And then my zeros are x equals 0, x plus 4 equals 0, which is x equals negative 4, and x minus 2 equals 0, which is x equals 2. So my zeros are 0, negative 4, and 2. Okay. Last but not least, I got some parentheses here, so in order to combine like terms, I need to distribute out these parentheses. So this is going to be x cubed, 8x equals 8x plus 8. I'm going to move these guys over. And I get x cubed minus 8 equals 0, and that is a difference of cubes. So let's go ahead and bring that over. So that's the situation right here. So I'm just going to take a little screenshot of this. Go ahead and move it here so I can use it. So if I have a cubed is x and b cubed is 8, then a equals x and b is 2, because the cubed root of 8 is 2. So now I can fill in this part right here. So I'm going to have x minus 2 and x squared plus 2x plus 2 squared. But we know 2 squared is 4. And we got x minus 2 and I'm going to have to equal 0, and I get x squared plus 2x plus 4 equals 0. And really, I can't think of any numbers that multiply to give me positive 4 and add to give me 2. I'm going to go ahead and finish this guy out. So I'm going to have to use the quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c. So this is a is 1, B is 2, and C is 4. All divided by 2a. Then I'm going to simplify, simplify, simplify. That's negative 2 plus or minus 4 minus 16, so that's negative 12 divided by 2. I know my factors of 12, and I know the perfect square that lives inside of 12 is 4. So when I take the square root of 4, I get 2. And the square root of 1 is I, and square root of 3 is not solvable without being exact. And then everything is going to get decreased by 2, so it's negative 1 plus and minus 2, not 2i, but just regular I, square root of 3, because I divide everything by 2. This by 2 and this by 2. All right, real or imaginary of this is 2 comma negative 1 plus I root 3 and negative 1 minus I root 3. All 3 zeros. Okay, if I have a question that says, what are the real solutions of the equation x cubed plus x squared equals x minus 1? You can use a graphing utility to find this. There's two different ways you can do it. I'm going to show you one way. The way that I'm not going to show you is you can subtract x minus x plus 1 from both sides and set it equal to 0 and find where it crosses. Otherwise, we are going to use a graphing utility. So first I need the equation. All right, so it's x, so I'm going to graph y equals the left-hand side of the equation, x cubed plus x squared. And I'm going to graph y equals x minus 1. And when we do that, we see that there is a one place where my two graphs cross paths, and that is right here at negative 1.839 and negative 2.839. So that's where the real solutions are. X equals, so if I was going to write that down, I would write x equals negative 1.839. That is the one real solution. Okay. Let's do this fun activity here. What are three consecutive integers whose product is 480 more than their sum? So I like this problem because it talks about consecutive integers. So a consecutive integer is like 1, 2, 3. They're integers that go right one after the other. You could be negative 4, negative 3, negative 2 are also consecutive integers. So think about what happens here. If your first integer is x and you want to find your next integer, you're just adding 1 to your original integer. If you want to find the next integer, you are taking your first integer and adding 1, 2. So when it says three consecutive integers, we're talking about x plus 1, and x plus 2. So so it says whose product, so I'm going to multiply these together, is 480 more than their sum. So that's x plus 1 plus x plus 2. So 3 consecutive integers, x plus 1, x plus 2, is, that's where the equal signs go up, 480 more than the sum of those numbers. So let's go ahead and simplify. So this is x times x squared plus 2x plus 1x plus 2 equals 480 plus 1x, 2x, 3x's. 1 plus 2 is 3. All right, so I'm going to combine like terms here. I got x squared. 2x plus 1x is 3x. And I got 480 plus 3 is 483. I'm going to distribute this x to everything in the parentheses. X cubed plus 3x squared plus 2x equals 3x plus 483. And I'm going to go ahead and subtract 3x from both sides. And I'm going to subtract 483 from both sides. And we get x cubed plus 3x squared minus 483 is equal to 0. I'm going to put this in my graphing utility. So come on, my graphing utility. Boom. So I want y. I want to know when x cubed plus 3x squared minus 483 is equal to 0. And I got 6.963 when I put in my graphing utility. No, I need to know when x is equal to 0 right here, yeah. 6.963. All right, so my little graph showed me 6.963. Well, if you look at what the question is saying, it says 3 integers. So I'm going to say that for this scenario, x is equal to 7. And then we're going to go ahead and test that. So if my first number is 7, my second number is 8, and my third number has to be 9. So I'm going to find the product of 7 times 8 times 9 and see if it's equal to 480 plus 7 plus 8 plus 9. When I do the multiplication here, I get 504, and that's 480. 789 is 24. So I get 504 equals 504. So my answers are 7, 8, and 9. Boom.